So today, I wasn't meant to speak to this. We're meant to have another private speaker for the public service. So twice this year, I've ended up speaking because the public servant couldn't get permission in time. So anyway, so this presentation tonight is actually one which I'm sort of going to give to RIMPA next week. So RIMPA is the Records and Information Management Professionals Association. So back in May, it was Information Awareness Month, and they had a sort of number of round tables, and sort of I hosted the table called Aligning Data and Information Management. So there's people from RIMPA, ALIA, and various other information associations, and so I was asked to do a presentation about, well, it's fine to talk about all the wonderful things about how we should work together, but how do we get started, and where should we focus to get the conversation going? So with information manager like RIMPA, records managers have quite similar to Dharma in a way, in terms of, they're trying to get their message across. They don't get a huge amount of attention. They have a problem with skills and things like that. So what's the message, or what's the direction we should think about? So that's what the sort of basis of this presentation is. So if I click the right button. So for data management, okay, so it all started back in the, I think the 1960s, might have been a bit earlier, but anyway, 1960s, with computing. So the idea was that we would take unstructured data, like names and addresses, invoice amounts, dates of payment of things, put it in a computer so we could process data. And so the whole of sort of data management industry has been based around this sort of idea of structuring data to put into a machine so it can be processed accurately by a computer to meet enterprise needs. Now, back in the 70s, relational databases came out, and so we had to be a big think about how does this work? How are we going to store data in a database and tables and things like that? And they sort of came around to the idea by the end of the late 70s that the way to do it was a sort of top-down approach, engaging many stakeholders as possible to build enterprise data models. So starting off with, defining the business terms, then developing conceptual models, logical models, and things like that. But unfortunately, so when I started my career in the 80s, we spent a lot of time doing data modeling and talking to business and things like that with models and things. But by the early 2000s, it sort of fell out of fashion. Everybody was too much data. So the number of actual operational systems increased, data warehousing had kicked off, data marts had kicked off. There was just too much data, and everybody got sort of bored. So we had these relational databases, and so the various companies like Oracle, IBM, and that, they all started to build their own sort of versions. And they all had different sort of features. It started off, just focus on a particular application, and they didn't really think about integration until about the 1980s or 1990s and things like that. So we got all these legacy systems all over government in Canberra, which were built, back in the 80s or something, or 90s. They've increasingly got more complicated over the years. They put in more and more data, and at the same time, they've increasingly been putting large text fields. So it's not uncommon to define a system like ISIS or in Service Australia or Promise in AFP, with 2,000 or 3,000 character text fields worth of data. And in that data, there's where all the interesting stuff is, like what happened in the case and things like that, or why did somebody phone? So then we had a burst of enterprise resource planning and this whole COTS and GOTS sort of thing, where you don't build a system, you buy one. So the problem was that with this is that it's actually the vendors of database, they never seem to capture all of the requirements. There's again increasing complexity, increasing costs and things like that, and problems with integration between these systems. So particularly in financial areas around government agencies, they have a lot of sort of off-the-shelf products, and there's a problem with integration and getting the right data. And again, text blocks. So, and then there's the data warehouse and data lakes. So we have, importing data from multiple solutions. So we need to know the, the state of the data in those solutions, but we don't. And so we're sort of building this thing where this idea of trying to integrate data to meet multiple requirements. But again, the amount of data is increasing significantly. The knowledge about the sort of systems is not very accurate. And, there's sort of high costs involved, either with a data warehouse and getting the data in, or in the case of a data lake, getting the data out. Then we move on to sort of methodologies we've been using, like Agile, which is very good for building a system, a state-by system, gathering requirements and things like this. But what it misses out is the broader information integration and other sort of issues. So after sort of like 60 years now, since we started to put data into computers, we really have this sort of a landscape where we have a large amount of structured data, which is in systems, which are it's hard to find, it's poorly documented. There's a lot of unstructured data in these ERP systems or point of sales device, and then there's a vast amount of information in in SharePoint or file shares or things like that, sort of feedback and use and things. So after 60 years of putting data in computers, we sort of got to the point where we can say we're not doing a very good job because it's not all accessible. The amount of data is increasing exponentially, particularly around sort of unstructured data, and it just when business can't access it. We have, huge amounts more data on the internet that people want to have, to interrogate. And so, agencies are hiring people to do the analysis on things which they could probably do themselves. So it's become a sort of getting to sort of a point where at the same time as all these troubles, that the government has high aspirations around data management and data literacy and data sharing and things like that. But overall, the fundamental infrastructure, if you like, the information infrastructure that's being built up over this time does not really meet requirements. So the result is that there is, multiple points of failure in this sort of application mindset. So building applications on applications and not having an enterprise view, which is now largely a whole of government sort of view. So there's points of failure around design, data entry, how we manage change and how we process data and things like that. So a major sort of issue, but I don't want to spend the whole presentation talking about the challenges in data management because there's a very good book here called Software Wasteland about how the application-centric mindset is hobbling our enterprises by David McComb. So I hardly recommend that book if you want to have a black owlman view of how IT is doing, or you want to give a secret Santa present to a CIO or something. But it is pretty comprehensive, and it's basically saying that we've come a long way, but we're not really getting the outcomes that the business they want. So the important thing is, at this point in time, we're actually at this inflection point where things are going to change. Of course, what's going to change in the landscape, and probably dramatically, is artificial intelligence, which is, has actually been around since the 1980s. The term. So it's been around a long time, and it's been evolving over the years. And really, it's sort of picked up speed in the last few years around machine learning and processing power. And large amounts of device data and things like that to sort of analyze good, well-structured data. So in any enterprise, if you stop and think about what people do on a daily sort of basis, people use language. So they go to meetings, they listen and they speak. They sit at their desk, or they read and they write. Or they might search for documents and things like that. So in any enterprise, and particularly in government, and most government agencies don't really have much in the way of device data or images to process or anything like that in terms of predictions. It's not done by many people at all. But everybody on a daily basis does involved in language, talking and speaking. And so language is about sort of, it makes up of sort of, to study language is sort of two fields. It's around linguistics, so it's a scientific study of human language. So what is the structure? How is it used? How is it acquired? How does it change over time, like that? So it's a major sort of structure, point of analysis or whatever. And then there's the different words and phrases and sentences that we use. So if you take a leg, a leg could be a leg of a pair of trousers, a leg of a furniture, or a leg of a race. You have a phrase like break a leg, which means you physically break a leg, or it could be to do with wishing you luck. So it's an expression, break a leg is used. And in the sort of ballet sort of profession, break a leg is a term that you might use when a ballerina is going on the stage, but a ballerina can also break a leg. So there's the concept of leg, breaking a leg, is sort of, has multiple different meanings and different sort of connotations depending on the context and the meaning. The second sort of field is around, as part of semantics, is the study of the meaning of the words in context and the relationships of words. So an animal is a mammal, an animal is a mammal, an animal is a bear, and things like that. So in the semantics and the sort of literature, we have Shakespeare writing about Romeo and Juliet, and Juliet describing what's his name, Romeo, in the sense of a flower. And we have other sort of writers writing about, say, a president of a country as though he's the captain of a ship, and things like that. So it's how we use the language of things is another sort of study, which is sort of complicated. So if we talk about AI, so the first thing is, there's two major types of AI. There's pure AI, which is like the idea of HAL, the robot, doing everything a human could do. So it's reckoned we're, maybe 100 years away or more before we actually get that full AI, and decades away before it replaces some, major jobs around the place. And then there's another part of AI which is sort of pragmatic, which is something which helps humans right now. So, it helps humans in the ways of predictions or recognizing, faces or images, or counting wombats and things like that. So it's a part of it actually helping, people with their work. So, and of course, so in the terms of an organization, pragmatic AI could be of best benefit if it focused on language. So, and removing sort of data silos and getting better outcomes for people and how they use and write information. So AI is not just sort of one technology. There's multiple sort of technologies. So there's three main sort of characters. There's one around data, which is around the deep learning, machine learning, and doing predictions and things like that. There's the physical aspects, which is robots and sensory. And then there's the ones which try to replicate the human sort of behavior or the human mind. So that's around image analysis, speech recognition, and natural language processing and natural language understanding. So what is natural understanding? So natural language processing, people have got quite familiar with due to Google and Alexa. So you can say, Google, turn on the lights. That's natural language processing, because that's a direct command, turn on the light, tells Google to turn the light. So natural understanding, you might say, okay, Google, I can't see. So it's an awareness sort of thing, given the semantics of the sentence and the speaker, around recognizing that actually is a command to turn on the lights. So in approaches to NLU, so from I think it was the 1970s or something to around 1990, most of the focus on AI was around this idea of symbolic AI. So it's trying to mimic the way the human brain works, and to train the computer to think and act like a people. So there was a lot of effort around that time, sort of trying to apply knowledge into a computer so the computer knew how to understand. So the point was that it didn't require any training, but it required a lot of human effort and time to manage and update the information and to get this pragmatic AI working. So around the 1990s, the sort of landscape changed with computing power suddenly increasing dramatically. And that's when sort of machine learning was born. And that was sort of based on the idea of teaching the computer to really understand data documents based on a sort of statistical analysis of the documents. So it can learn complex patterns in data, and it requires less subject matter expertise in the actual content, but it requires a lot of expertise in the data scientist developing and building the application. But the weakness of it was it required a large amount of data, and it wasn't always. Things started, the information changes and things like that. The data would have to be retrained and rerun. So there's a large overhead. So what in the ideal world is this idea of a hybrid. So where you use both human knowledge, around the words, if you like, or images, and then you leverage that with machine AI to do it at scale and speed. So it's leveraging both the machine learning and symbolic AI in tandem. Where that could be useful is in an organization where you want the one sort of platform that can leverage multiple different capabilities. So AI and NLU, there's here on the screen, I've got about 4 different categories. So on the sort of left-hand side, there's machine learning categories. And on the right-hand side is largely the sort of knowledge-based approaches. So machine learning, most basic, is simply processing an invoice. More complicated will be assigning medical risk assessments and codes, putting a severity of things, and more of a sort of rules-based assessment. And then there's the sort of process automation, which might use some voice and text input on the knowledge side. So it has to know the words and what's going to be used because you want to make it reliable. And then finally, there's a sort of top of the thing is this advanced linguistics, where you want to process and understand complex documents. And how it's in the documents is complex and it's difficult to understand. So at that point is when you really need to have that human knowledge applied to do it. But within any organization, there's multiple use cases that need to be the NLU could be used for. So this idea then that natural language understanding is actually an enterprise system, an application. That can ingest any sort of text in any sort of form, apply statistical processing, apply the knowledge graph of what the data, the applied knowledge, build a knowledge graph, and then use the data in that knowledge graph to support a range of different business processes like process automation, and document categorization, chatbots, and things like that. So the idea of NLU then should be seen as an enterprise platform that's sort of bought. So what you want to do is to have a single platform that can meet all those sort of requirements. It can provide the flexibility and avoids the sort of application-centric view, which has been happening, or we've seen a lot of in the IT application sort of world. So, so about 5 years ago now, I was doing a data strategy for an environment agency. And the thing I noticed was, or the problem I had was, they wanted a strategy for structured data, but there was very little of it. There was lots and lots of unstructured data. And so that got me sort of looking around the world to find a platform that could actually analyze all the unstructured data, and more to the point, extract from it the data, the data which is hidden in reports and things like that. So I didn't know anything about AI at the time, but I was given some advice, and there's this company called expert.ai in Italy. So they basically founded in the 1990s. They didn't give up on the symbolic AI, and they spent the next 10 years building this sort of knowledge graph in which it has all the words and the nouns and the relationships between the words and the nouns. It includes all the diseases, drugs, environmental factors, and things like that. So it's a very broad and deep sort of knowledge. And it also is used in 14 languages. And in Europe and America, it's used by 200 odd organizations, ranging from large banks to insurance companies to government agencies to media and publishing and plenty of others. And it's basically become a sort of enterprise NLU tool of choice for large organizations around in Europe and that. And it's also got lots of validations from Gartner, Forrester, and it wins just about all the NLU and NLP awards that have come out. So it just won what was the one recently? About innovation, knowledge management, training, setting products, and innovation. So last year, the Stevie Awards, the Business Awards, won for innovation in business, and it won the Bronze Award for COVID response. So to give you some idea of what it does, I'll just run to a couple of slides. So you can take a sentence like, the governor pen gave Peter a pen and asked him to pen a story about a flightless pen. Now in that sentence, there's 4 different uses of the word pen, and therefore the meaning of the word depends on the context. So the first context is about a governor of an area or administrative area. You gave Peter a pencil pen, so that's a writing implement. Asked him to pen a story, so that's to compose, and to then about a flightless pen, which is a swan. So in order to do that, you need to have that, the link, or to break down accurately what this sentence means. You need to be able to know what are all the variations of the word pen. So on the right-hand side here, that they have pen, all the different things around. It's used in zero techniques. It's something something written by a particular person, a penitentiary, correctional thing. It's a fortified dock for repairing services submarines. And then there's the words around it, compose and to write and things like that. And on the left-hand side, you can see that the pen is a writing implement, is a tool, it's a simple tool, it's an instrument, and things like that. So you categorize it semantically. And underneath, you can see in the sort of child concepts, a pen can be a quill pen, a felt pen, a music pen, or a drawing pen, and all these types of pens. So having that sort of knowledge, as a basis when analyzing text, gives you that extra knowledge that can then be leveraged by the machine learning to get a good understanding. And so here, so you can take a sentence and build a knowledge graph. So here's a simple, from that simple sentence, you can see how it's drawn out that it's about a person, that the sentence is about a title person, being the governor. It's the concepts about literacy work and prose and things like that. And so all the concepts are there, as well as the verbs. You can do a deep analysis and then also, build the relationships between the different words as to what they mean. So around, there's a governor pen, gave Peter a pen is the first thing. The second part of the sentence is about asked him to pen a story, and the third one about a flightless pen. So it does that sort of deep analysis into a document. Now, I'm not going to give it any more than that. If anybody wants a sort of demo of it, then please be in touch and I'll give you a full demo. But the point of it is that if you can understand documents and you can understand language in depth, then it opens up a whole lot of use cases around intelligent process automation, around cybersecurity, around R&D support, knowing your customer, and things like that. And at the same time, it can provide a very rich source of information to support, existing applications. So enriching your financial system with the reason for transactions and something like that. So you can actually use it as a source of data, reliable source of data, based on all the unstructured documents and things within an organization. So in Australia, it hasn't really sort of grabbed the headlines yet. So there's this paper written by ACMA about natural language processing technologies in government. And in the document, it's a very good document, but it does say one line when it talks about the challenges. It talks about training development timeframes. Internal NLP design implementation requires prolonged effort and multiple testing and development cycles. So that sort of says that what they're thinking of there is that it's a machine learning. NLP is a machine learning enterprise, and they're not considering that the fact that you actually need that knowledge base to actually build upon to get quick implementation. So why expert.ai is popular in Europe is because it can, you can get stand-up approach, you get 4 to 6 weeks, and it's reliable and it's ongoing. So when I first sort of met expert.ai, it was a data scientist. So 5 years ago, it was the data scientists who were going to expert.ai saying, look, business want us to get more reliable results. Can you help us at that? So, and now today, 5 years later, EY, Accenture, Capgemini, and PwC, they're all partners of expert.ai in Europe because they all know that to actually present themselves as a viable digital transformation consultancy or implementation capability, they need to have some form of enterprise NLU sort of capability. But in Australia, they don't reply to my emails, so they don't seem very interested in what is going on over there. But anyway, so the whole point of this, this presentation is really around the fact that what's the impact going to be on data management around AI, and particularly around NLU, because having worked in data management, been in Dharma for years, it just strikes me that it's a time for change, and it is a time to actually reconsider what are we really about, and this idea that the days of just thinking about structured information and managing structured information are really drawing to a close quite rapidly. The AI and other sort of applications is going to rapidly, increase. I'm sure here as much as it is already happening overseas and things like that. So data management profession is going to be under pressure, and therefore what we worry about today is going to change. So I'll just run through some of where my ideas where change will happen. So the first thing is that if a computer can understand and read unstructured text and understand the document, tell you what's in it and process it accurately, then we don't need to structure a huge amount of all the information, and we really just need to focus on 3 sort of categories. So the top one is around the catalogues and reference data. So it's around the catalogues in terms of the classifications that we use, the semantics we use, the definitions and things like that. And the next 2 is around master data. So we need to have a reference point. So Andrew Smales, if they come across my name in a document, well, who is he? That's fine. So I'm male, live in Canberra, here's my picture and things like that. So master data, I think, will become increasingly more important as a way of actually supporting that sort of linguistic understanding. And then the third one, it will be transaction data. People will still get paid, they'll still be have a phone call, but it won't need to worry about the content of the call, or you won't need to too much worry about why you got paid, because that could be derived directly through NLU and through looking at the underlying data. So the second big area of change is around definitions and how we view the definitions. So at the moment, we'll sit around, we'll think about how the data, what's the meaning of the data for humans. So we'll take a date, and somebody will come up with a definition around the date, and then we'll seek agreement amongst a lot of people around what does the date actually mean, and then finally get a definition and prove it, and store it in a tool like Aristotle to manage. And so that's sort of like the current mindset is we're trying to make data understandable to humans. But in the future, it'll be around making the meaning of words understandable to computers is as much as important. So though we more likely into the future, I think, be using classification and linguistic tools to analyze what's actually written and how we actually use it, words and phrases in documents. Then we get sort of agreement with the humans that that's what they mean. But then the second sort of part is around, well, if we find that word and we find that entity, what do we extract, and so that we could classify, documents and machine learning or automatic processes of things. So there'll be much more of a hands-on looking at existing documents and classifications of documents. And so I could see in the future, data managers working much, hand in glove with records management and other sort of information professionals in that sort of area, in the analysis of building around the semantics and things like that, which would support the sort of NLU and sort of processing going forward. So the second sort of big area of change is reference data. In the last, I don't know how many years, I don't think I've ever crossed a department considering reference data as a thing. So at the moment, data strategies, data governance, data quality, metadata, and things like that. But going forward with machine learning, with robotic process automation, things like that, it all really hangs off well-managed reference data. And so that the sort of classifications, the codes, and things like that can actually, be used by multiple applications consistently. So I can see, the reference data will have a much bigger role, and there will be, of course, the classification schemas for the unstructured and data that we include in there. There'll be reference data from external sources that will need to be managed too. So probably a lot of emphasis on reference data will actually be at a whole of government level to support sort of open data, sharing data and things like that. And then internally around, NLU processing, knowledge graphs and applications inside. So the next area is that currently we spend a lot of time and money building screens to enter data. Well, I can't see them hanging around, because if a computer can sort of understand text, well, really all you could do is you could write an application to say, I'd like to apply for, Service Australia grant, this is my name, address, and things like that, to write that down. You could send it in, and then the computer could send a thing about, but you didn't give us your date of birth. And that. So you can see going forward that with NLU, there'll be a necessary requirement to key in data into screen, and screens will slowly go. And therefore, with the chatbots and speech-to-text type technology and use of that, we will have better quality data being entered from source, because the robot can sit and argue with you around, well, what do you get this data right? So it'll be given a rule based on a knowledge graph and things like that. It'll be something you can build on over time. It's not as though you're just building something and throwing away for a particular grant or something like that. This rule-based development will enable quite complex applications and processing and capturing of data over time. So the next major use would be around knowledge graphs. Give knowledge graphs have the ability to suck in unstructured data, analyze it, integrate with external data, and then present it in a way that can be analyzed by a computer or by a human or whatever. So in this example here, this is an extract from an article from the BBC. You can see it's been integrated with Wikipedia. So we got the Scott Morrison's face in it and things like that, and behind there you've got his role, his gender, and things like that, which wasn't in the article. So the use of knowledge graphs to actually enrich the data sources and make it available for processing will increase. So the next one, which anybody working in data governance requires a huge amount of information to manage well. So if you look about where the data sources are, the information needs, the business data models, what's happening in infrastructure and things like that. So data governance in itself is a major user of information. And at the moment, we have few tools that will actually provide that sort of integrated view. So I can see in time the data governance, the role of data governance will actually be based largely on sucking in documents and analysing documents, technical specifications, business requirements, and things like that, and then using that for analysis and reporting for data governance. So the sort of next to last thing I think will happen is this idea of semantic interoperability and having the same sort of semantics and consistency in analysing documents. So these are, the sort of taxonomies that you can get out of the box around crime, cyber attack, malware, as well as emotion. So we can say, from the documents, we find the documents that have around stress or sadness or have a health fanaticism. I haven't seen that one before. But so if you have this sort of idea of semantic consistency with people using the same sort of tools, or at least recognizing sort of difference, across government, that'll heavily, support the idea of open data and data sharing and things like that, because we resolve the complexity of meanings and things and dealing with external parties, and of course it works in different sort of languages too. So the final thing is really it's around this idea around documents, reports, research, which tends to be sent in, it's stored in emails, it's stored in SharePoint, it tends to be all over the place at the moment. A lot of enterprise search tools. It's very difficult to find documents. As one agency spent a lot of money implementing a search tool to find the documents. But they then get an audit because they can't find particular documents. So what I can see into the future is that actually there'll be just one version of every document, and NLU will be used to make that document accessible and actionable by systems. So it doesn't need to be recorded in other systems or duplicated. It'll be stored in a single knowledge graph that supports the whole sort of agency's requirements. Now then, you might think that's all a bit over the top, but sort of the ideas. But so this is just one sort of use case which is implemented, and so you can follow there's two links at the bottom there. You can see it for yourself. So it's 3M, and they have this automation process for doctors. So when I last went to the doctor, the doctor spent 80% of the time looking at the screen, typing in stuff, searching, and things like that. So in this sort of use case, the doctor speaks to a device, natural language standards, understands it, then pulls out the text and makes it structured. The robot then sort of sorts out the thing, that decides what was talked about and what are the medical codes and things like that. The doctor at the end of the thing then looks at the thing and agrees on the robot's sort of findings, presses enter, and then all the sort of following sort of treatments, orders, medications, pharmacy, and whatever is automatically sort of processed. Now, the doctor, the medical sort of language is very complicated. So you can imagine the complexity needed to do this. And so this sort of idea of talking, or just sort of getting a computer to talk or read to based on a bit of information within the average sort of government department is actually probably quite a straightforward exercise, sort of believe. So, and you can see around the world that this is the best example of, you can see where it's going, was Microsoft paying $19 billion for Nuance, and this is basically the use case they were paying for that amount of money. So, and it's not an exclusive use case because 3M has done it too. So there's going to be a lot of use cases like this happening and occurring around, processing and analysing unstructured data. So just to finish off, go back to the aligning data information management. So, for us professionals working in data and information, it's quite clear from May, and I think other things, that we're at the moment we're just all sort of pigeonholed into various roles. And actually, if you actually look at AI or the future, then we all need to actually come out of the box a bit and actually talk about how are we going to, what are the challenges, how are we going to meet those challenges into the future, and how are we going to do it in information, an enterprise view, to sort of avoid the costs and risks which we currently sort of manage in the sort of application and IT sort of world, and the complexity that brings then to data managers in trying to bring data into shape and make it shareable for open data and things like that. So there's a major sort of I think a major requirement to start that conversation, and the sort of the ideas I got here around NLU. It's sort of like, well, this is the way I see the sort of things are going. But if people have alternate views, well, we should book a spot and do a presentation to Dharma Canberra. We're going to start looking for presenters next year, and so it'd be good if we get some people coming up with alternate ideas. So finally, any questions? If you want a demo of expert.ai and see what's sort of possible now with natural language understanding and what are the sort of use cases around the world, just give me an email to Raiden, or if you want to present to Dharma Canberra, email Canberra branch head at dharma.org.au. Thank you.
Any questions? I've got the chat open if you, but equally, I think you could turn on your mic if you want. I'm not sure if that's possible. Any questions? Can't see any in the chat yet.
No questions.
Thanks, Mark. That was a nice compliment. Right, here we go. Andy Payton. It must be a challenge to take an enterprise view versus a project view.
Yes. I think that's the hub of the question. I think so. As I said at the beginning, we use enterprise data modeling as a way to get that enterprise view, structure around structured data. So I don't think we're going to go back there in any hurry. Being organised the Data Modelling Zone conference, it's not a bestseller. People, aren't rushing back to learn around data modelling and how to manage unstructured data. So this is why I think going back to language and using language is probably the way to go in getting that enterprise view. So it's getting the enterprise understanding of the importance of language. Involving the records managers, the IT people, and data scientists and things like that, actually coming up with a common sort of approach to how we're going to deal with these issues going forward. Otherwise, we'll simply run the risk of having multiple AI solutions, and it'd be just a nightmare to manage. So I had a conversation with Brendan Dalton, who's a CIO of Saro, about 2 years ago, and so he was talking about the fact he's got all these Nobel Prize winning data scientists who've done these fantastic projects, but you just know the next project is what people want to integrate their results, but the data's not in shape. And so I think there's the pressure's on to actually come up with an enterprise way of doing this. Otherwise, it's just going to be a mess, like we haven't seen before.
So, a question from Louise Edmonds. Can you expand on the reference data management and how you would see a controlled approach across a multi-campus platform working?
Well, I think it's when you think about reference data, it's simply the codes management about how the systems and things are generated. So to make it working, so ISIS, which is was Centrelink's major system and the major payment system within Centrelink to this day. It was founded back in the 80s and 90s. And it's the key to success is the fact that it's all reference data generated. And so people aren't writing code. People are generating code based on reference data in the data dictionary. So I think in answer to your question, it's about automating code. And so it's not down to people writing it, it's about automating it. And that way you know it's right. There is no way that ISIS could have met the sort of demands that people, thrown it over the years, the major change, without it being code generation, without it being automated, the code generation. And so that's the first thing, the code has to be generated. The second thing is then in the sort of process automation part, using UiPath or Blue Prism, that requires codes. And so in that sort of thing, it's around making certain that whatever applications are using codes or process automation or analytics or something like that, it's enforcing standardization. Now, enforcing standardization means you actually get people in a room and you have to have some sort of formal way of making sure that people are doing the right thing. And it's not, the trouble with Agile is the bit they miss is the formal review of what's been done, the sort of quality assurance walkthrough or whatever.
Okay, thanks, Andrew. Another question from Lynette. It looks like unstructured data becomes structured in knowledge graphs. Is that correct?
Yes, it becomes accessible and structured. It's structured in the sense that it, pulls out the entities and the various nodes, and then the relationships between those nodes. So it's a very sort of fluid structure. So I think next month, what's his name? The speaker next month.
Oh, yes.
Yeah, Marcus will
Marcus.
Far more expert in knowledge graphs than me. So come and listen to next month's presentation.
Very good. Okay, Andy Payton. Is AI available as a cloud service? And do you think that voice data entry will become the killer app for AI?
I think if you look at the Gartner, Magic Quadrant, what's the flow one? Gartner's, Trough thing or whatever. But a wave. So those Gartner wave things. If you look at that, the language or speech recognition is one of the most, is furthest along towards, acceptance. And that's sort of why, Microsoft buying Nuance for 19 billion or whatever. So it definitely, I think this speech recognition is something that is already here. And, something we could use in chatbots and things like that. I think there's huge potential there.
Okay. Simon, but how much confidence should we have in NLU? How will we know how well it is working? We already have a disquiet about not understanding algorithms. A la the Facebook, we want to know, what are they doing? What is the algorithms Facebook and YouTube use, etc. And we don't like that.
So a platform like expert.ai is rules-based. So it's not based on an algorithm. And so when you're understanding and reading a document, you're applying and writing rules, which you can remove bias and things like that by doing that. So you're looking through the text, identifying the concepts, and then you're extracting what information you want. Now that might be a high-level classification of the whole sentence. So this sentence is about somebody walking their dog, or it might be, the name of the dog or something like that. So you actually write rules. So it's explainable. So you can actually, look at the rule, look at the outcome, and then fix it. As well as, it's highly accurate. So I think what Simon, you're referring to, machine learning has had this problem of actually, how do you actually verify its accuracy and explainability?
And Sarah Lauder, do you see the analysis of unstructured versus structured data merging?
Yes. And, I think it'll happen in scale. If you think like I was, working in industry, they have a lot of application data that comes in with each application for grants and things like that. that is largely not analysed at the moment. You know, in programs in Service Australia, they like to know, you know, sentiment analysis of you know, transcripts and what people talk about, complaints or things like that. If you look at AFP, they've case notes. What does the case note say? What is the detail in those case notes? So there's plenty of applications and plenty of requirement across government agencies to be able to analyse what's in unstructured data and turn it into some sort of structured form. You know, the one part of it, but just to analyse it and find out what it is, where it is, and what they say, and things like that. I think there's a government agency that would not have some sort of application understanding what's in unstructured data.